All right, what's up, guys? Just coming at you with the first C++ video. So this will just be a little introductory bit. Go over some of the similarities and differences between C and C++ syntax. Remember, this is meant to be coming or directed towards somebody who has a background in C. You don't have to be some pro. You don't have to know exactly how dynamic memory works and all that, but a little bit of basis will just help making understanding all these concepts a lot easier. All right, so you should recognize some of these from C if you're coming from there, right? Ints, floats, chars, bools, arrays, and such. You know, some of these even down here maybe, but they're going to be a little bit different. That's kind of why I divided here. So these, for the most part, all exactly the same macros, with the small exception of like string variables and bools. You do not have to import like special libraries for. You didn't technically for this one in C either, but they're just like pre-built a little bit better in C++. That's all I'm trying to get at here. So as you can see, I have a empty C++ file here. Comments work pretty similarly too. Okay, so multi-line comments right here. You can comment out stuff from just a ton of lines, and these ones, the little single line, double slash, forward slash ones. Okay. Now let's include our first header file. Okay, so very similar to regular C. We're just going to hashtag include, get our brackets, and this time we're just saying IO for input output stream. Okay. And you don't do .h like you used to in C. Okay. You do .h if you actually have a header file you've built yourself or something. For this sake, we don't. Essentially, if it's in these little brackets, just assume you don't. Okay. Now, we're going to say int main, and we're going to give a regular old main function. Okay. We're not going to give it any command line arguments, but those function pretty similarly too. But I'm just going to make that void for now. We don't even need to worry about them. Don't let them get in our face. Perfect. So we got our code in here, and that's what's going to happen. Now, there's so printing and using output functions we'll get to in a second. Those are a little different, but let's just take a look. So int, something a. We're just going to use letters for all these. Int a equals 10, right? So integer is the same, like I said, float. I don't want to have to go through all of these, but I'll just, kind of leave it at this. Okay, so we have a lot of these that are going to be the same. If we're going to make it array, you give it some size in here, and now it's an array. That sort of thing, okay? And it doesn't like that syntax now because, I didn't give it enough things. It wasn't curly braces and all that. So data types are very similar between C and C++. One of the exceptions being, we used to have to make char arrays in C if we wanted to handle a string literal. Remember, a string literal is anything you have right here, right? So anything you have in a set of quotation marks is a string literal. I'm a string literal. Okay, so that's just going to remind us what this is. So we used to have to give it some char array. Okay, and with, again, a size in there, and set that equal to a string literal. And I think you might have even had to do that with a pointer. But point is, you don't have to do that anymore. Pre-built in now is just a string data type. Visual Studio's code doesn't like to, I need to give it a name. String C. Okay, so Visual Studio's code doesn't like to color it correctly for some reason. Oh, I know why. Okay, so here's where we're going to run into our first little interesting bit. One thing where like this ISO stream or IO stream differs from the C hashtag include stdio.h is that we need to have what's called a scope resolver or a scope resolution operator. They have lots of different names. Point is, we have to say using namespace std. And what you're going to see is that goes away right here, right? So we don't have an error here anymore. Now, if we were to go here and do our C out, so that's going to print to the terminal. And normally with the printf function, it would be something like that, right? Where some function, we give it a parameter. In C++, for some reason, they decided that writing to the terminal would be a little different. So you C out for console out, and then you want to give it some string literal. So you could say hello world, right? And then you give it another, these just, think of them like commas, right, between stuff. Then we want to say end line, okay, end L. That's like our new line character. We don't have to put it in here anymore, although we could still do that. That's perfectly valid. Now we'll get even more new lines. So let's copy this down once, okay? And let's see it in action for our string variable C, okay? So C wasn't a great name to give it, but you can see how we've given it a variable in there. And I don't know why it has that, but okay, that might have a problem for us, but we'll give it a go. Okay, so GCC. Oh, actually, here's a good point too. When you're compiling a C project, you don't use GCC, okay? That told us a specific set of instructions for C programs. We don't want it to use a C compiler. We want it to use a C++ compiler. So we're going to use G++ main.cpp is what I called it. For those of you who didn't know, .cpp is what you use as a C++ file extension. Next we hit enter. And it looks like we might get an error because we have a problem according to Visual Studio. Okay, no, so it didn't get an error. It could just be a Visual Studio's problem. Sometimes they do that. Yeah, perfect. So it printed out exactly like it was supposed to. I don't know what its problem with this is, but I do have kind of an idea. Basically, using namespace std is not a very good practice. Why I'll come back to way in the future. But say we wanted our code to work without this, okay? What do we do to make it work? Okay, so let's just say we're here. How do we make our code still work? All these have problems. And that's because we have to, that was called a scope resolution agent, but there's another type too. So we can go std, right? That's what we said to use earlier. : Now that works, okay? If we were to copy that here, every instance that we use these, okay? Now if we were to rerun our code, it would function exactly as it did before, right? So hello world, I'm a string literal. Now, why this is all about the actual object-oriented part of C++, which is not something to cover in just like an introductory video. So for now, don't worry about using namespace std. Std, yeah, that's right. Okay, using namespace std. So it's nothing to worry about right now. It's just as soon as you start including tons of files up here, these header files, you could run into an issue. That's the reason it's considered bad practice. But we're not going to worry about that too much right now. So I'm just going to comment all these out because I have it already in the header, right? So we know this works. We ran it earlier. So let's look at what are our other types, right? We talked about these. Bools are the exact same, you know. We talked about arrays, macros. So if you, just a quick reminder, a macro is when you say hashtag define pi. It's probably best to do all caps because usually we want to do macros all caps. 3.14. Now pi is a macro which we can call at any point in here. So I could even, you know, do something like this. I think you can just put a number right there. I don't think that's a problem. Say pi. So I'm just going to leave that there. And so here, if we wanted to, we could even say this. We could give it a literal right here, which is pretty cool. So pi equals, and then it's going to print that out and end the line. I'm not going to run that quite yet, but that's what a macro is. So just, you know, in case you need a reminder, exact same syntax. I already talked about the difference between strings were. Static. So static is a new thing. So you know how with ints we could originally say unsigned, right? That still works. All that's fine. We could do the same short. Ooh, short. So, you know, all those carry over exactly the same too. But now we have one called static. What is static, okay? Static means that the variable is essentially always there. It always has some place in memory, even when it hasn't been run yet. So say we were to cut that out of here, put it way at the bottom. Now, essentially, once this is created once or something, like once it's created once, it's never going to need to be, it doesn't get destroyed. So normally with this float variable, if we were to put that in another function, So we have some void function. Okay, so we have some void function, and we create an int something, right? Or let's even call it imp temporary, temp equals 5, okay? As soon as that function is run, the int is created, maybe it gets returned, and then it's never thought of again. It's actually even erased from memory. So in the sense that its spot is not being allotted. I don't know why that's a problem either, but oh yeah, because there's supposed to be no return value in a void function, my bad. So just, you would have something like that. This is created every time the function is called. Say we had a static int in there. This is just always there in a way. It can't be called. Like, thinking it's always there doesn't mean I can call a up here and it'll actually work. But it does mean that it's not constantly being like destroyed and recreated and destroyed and recreated, etc. So that would be some function, right? We're not going to call that. As you can see, though, defining functions is the exact same for the most part as C++ too. And you're always going to have a main function. It's always going to know to do the same thing. Really, they're not too different of languages, so you shouldn't feel concerned about having to learn them at all. As you can see, we have our pi macro working fine. Again, ignore that one error. It's just a Visual Studio's bug. Oops, sorry. I meant to click in here. Lastly, we have objects, okay? So objects, what are objects? You may have heard that C++ is an object-oriented language, okay? And so I think the best way to visualize an object is with what's called an object literal, okay? So we're going to have a struct. It may not like me, okay, it doesn't mind me defining this outside of a function. Typically you give this some name too, but name. No, we're just going to give it struct name. And so you would use a struct, and you could do these in regular C too to essentially create object-orientedness, but a string literal, quite shortly, would be the same as if you'd said name, like some normal variable. Let's just imagine in a perfect language, you could say object name, like a variable type, equals something, an object, right? So what is this object? Well, an object is some name and value. So an object is a pair of a name corresponding to a value, okay? So let's just call this one object thing for sake of not confusing those. Okay, again, keep in mind all these errors are fine. We're not going to actually run this. This doesn't work. In objects, objects can kind of function as arrays. So you could have a bunch of things. You could have name 2 and give that a corresponding value. Oh, geez, I can't type. Okay, so you see the point is that it's kind of like a variable, right? So imagine that we could have this object thing, and I think another good way to imagine it, it doesn't actually work like this, but imagine a object as like an array full of variables. So you have int name equals, 10. Int name 2, right? And you see how that kind of works. If you could have an array which stored a bunch of values and had variables, each one with their own ability to have a name and something to remember, then that's very useful, because now what we're getting into is now this object thing could be object employee, right? And your object employee is going to have a name. He's going to have a name, right? So we could say his name is John. And then he'll have a salary, or you could even just say pay. So you have a pay, and that could be, just make him 70,000 per year, right? He's a good off. And he could have all these other things, right, that go into an object. And now say we want to have another object employee who is named Sally and gets paid a different amount, right? So that is the whole purpose of object-oriented coding, is that we want to be able to have these objects. These, again, keep in mind, this is an object literal. In the same way this is a string literal, right? These are object literal, so there's actual depictions of what it means to be an object. And this is a depiction of what it means to be a string, which is just a char array. So this is the essence of C++. This is why the language is essentially created. And just to give it C this capability to be able to do stuff like that. Now, an object in here, though, you can't exactly, again, you have to use a struct, like I said, to define something in there. I simply wanted to just go over kind of what an object literal looks like, though, because there's not a great way to just say like string C, object B, whatever you want, and make that work. But you should have a pretty good idea of like kind of what an object is. Just remember, it's like any other variable. It's a name and a value, but it can be a bunch of those kind of stored in an array in a way. Sorry, there was no real script for this, my little TED talk here, but I just thought I'd kind of try to like slowly ease you guys into understanding the differences between the syntax of C and C++, but also showing you, hey, they're not all that different either, So don't feel intimidated by this change. Sometimes, again, it's hard to worry about like learning these hard concepts like objects and higher level programming while also trying to worry about syntax too. But keep in mind, it's all foundational. It builds a lot on what you already know, and you'll be good. All right. Thank you guys for tuning in. I think I'll have an intro to object-oriented programming coming up pretty soon for those of you a little further along. Thanks for watching. I will catch you guys in the next one.